Okay, so here's the another MathCON problems, geometry. So what we are given is a trapezoid, which is a common type, and AB and DC are parallel, and now we are given some sort of angle relation, and AD and DC are 1, and AB is 3. Okay, so it's not really clear how we can actually draw the trapezoid, but at least we can start with one and see if that's gonna be useful. So let's try and start with that. It's regular random any trapezoid. So I'm not gonna label right now, but if I have these two parallel, and I don't know which one is which, but I usually start with either on the left top or left bottom, which shouldn't be too different. If you try the other way around, it doesn't make any difference for the equation. So I'm going to start with A, and I'm going to go with B, C, and D. Okay, so the AB and DC are parallel. Okay, AB and DC are parallel, which is good. We are good with that. And then twice of ABC, A, B, and C. So this angle, maybe I should, okay, let me use this one. If I call this is alpha, DAB will be, this is gonna be 2 alpha. Anyway, but let's try that. And then AD and DC is 1. So this is same as this one. These are 1. AB is 3. Okay, it looks like my figure looks fine. And we are looking for this guy. Okay, so here's a question that you need to ask. Like when you have at this step, you need to ask yourself, how do I use 1 to 2 angle ratio, right? That's given, and then we need to use it somehow. In most cases, it's good to split this 2 alpha into alpha and alpha. But when you draw the angle bisector, you have no idea if this is gonna cut the C or if that line goes through C, maybe something other side, but we don't know that yet. But at least I do think I should be dividing this angle alpha alpha, which is why I'm gonna delete that part. And what I'm gonna do instead, I'm gonna connect A and C, because this figure much better than drawing this segment some other pieces, because at the same time I do know this is isosceles triangle. If I call this is some degree angle measure, this is going to be same as that one. So let's say this is let's say beta, then this is going to be beta, and I do know this is parallel to that. So this angle beta and right here should be beta. As you see, this angle became 2 beta, but we did know that this was 2 alpha, which means I can actually say that when I draw that diagonal AC, that will actually split this angle into 2 equal pieces as well. So it was twice of this one. So I can say that now this is gonna be alpha and alpha. I hope that makes sense. And now that's actually not too bad, because I have alpha alpha, which is 2 same angle, and then in this triangle I have alpha alpha 2 same angles, which tells me the triangle ADC, right? ADC is similar because you have 2 same angles. And if I start with alpha, so I can go with ACB. So triangle ACB. And now let's try the ratio. So if I start with 1, which is corresponds to, I'm going to call this is X. That means this is also X. 1 over X is equal to, and the other side is also 1. It doesn't really make any difference. And then this angle is opposite to X. And the same angle right here opposite to 3. So if you do multiply, so you got x squared is 3. So the x should be square root of 3. And this is actually what we were looking for. And we are done with this. Okay.